Okay, ladies and gentlemen, the last question from section 5.1. We're finally there. If I give you the function f of x equals 2/3 x plus 1, and I give you the function 3x minus 3 over 2 and claim that it is the inverse of that they're inverses of each other, how could you prove it? Now, sometimes students tell me to use a calculator to look at the graph and to see that the line y equals x acts as a symmetrical comparison. However, for those of you especially going on into the pre-calc course, when somebody asks you to prove that two functions are inverses of each other, they really want you to do it with the operation of composition. So what we have to do here is we have to take f composed with f inverse of x, and we have to see what that turns out to. And then we have to do the other direction, because composition is not commutative. So basically, to prove that two functions are inverses of each other, you have to do two parts, and you also have to start with x, and when you compose these together you should end up with x. And part of the reason behind that is what that means is what this function did, this function undid. So let's start. Let's find f composed with f inverse of x. And if I write this would be f of f inverse of x. Not working with the f yet, I'm just working with what claims to be the inverse function, which is 3x minus 3 over 2. And now I am supposed to take this entire thing right here and plug it into function f. Well, f takes 2/3 times the input and adds 1. 2/3 times the input and then plus 1. 2/3 times the input plus 1. Okay, what would happen here? These 2's would cancel, and we'd have 3x minus 3 over 3 plus 1. But this 3 divides into each part of this, leaving me with x minus 1 and then a plus 1, and that becomes what we wanted, namely the desired x. So if I start with x and I compose f with f inverse, I end up with x, which basically is saying what one function did to it, the other function undid to it and left it unscathed. But you can't just stop with one direction. You've got to compose in both directions, because composition is not commutative, so you have to convince me that both directions are going to work. So this time we do f inverse of f of x. F inverse is not the first function we use. The first function we use is f of x. So we take f of x and then eventually plug it into f inverse. F of x is 2/3 x plus 1. And now this whole quantity gets plugged into f inverse. So anytime in f inverse you see an x, you're plugging this input into it. So we end up getting, that's f inverse, 3 times what we're plugging in minus 3 all over 2. Alright, and what happens here when I distribute? The 3's cancel and I'm left with 2x. 3 times 1 is 3, and then I get a minus 3, and I'm all over 2. When I collect like terms, I get 2x over 2, and that becomes x. So now we've actually done a proof that the two functions are inverses of each other. This is considered a mathematical proof, so we can claim that yes, they are inverses of each other, And a lot of times in math, you end a proof with the symbolization QED, and that is Latin for quo est demonstratum, which means which is what we wanted to demonstrate, or which is what we wanted to prove. And we're done.